Hello everyone, we are Team 8, also known as the Boiler Bums, and this project was brought to you by Mark Rome, Hudson Reynolds, Jonathan Slager, and Evan Mesher, and we're excited to show you what we did for our final project.
About 40,000 students and faculty commute around Purdue every single day, and with all this traffic, we need to make sure safety is the number one priority. We've been tasked with designing a device to do just this, and we have a few criteria and constraints set for ourselves. Our design must utilize modern technology, including a TI P401R microcontroller and Fusion 360. We also want to make sure that the design fits with the aesthetic of Purdue and is economically viable so that they are more likely to implement it. The stakeholders in this situation are Purdue University as well as all of the walkers and bikers who commute daily.
Today I will be talking about a brief review of prior art and their limitations. So, one prior solution would be a CAS system where there's an antenna between two objects that alerts them. This is used in airplanes, but one issue this would be that both items need a receiver, which will not work for a pedestrian easily. Another is adaptive autopilot software, just using distance sensors to tell what object is what, but that can be hard to code. A third option would be navigational lights, which would be a visual only, and only works for low speed. It's hard to tell at high speeds. And then the fourth option, or the simplest, is just reflective material, which just needs a light source from the object though.
We made a total of 3 prototypes, but we decided to go with one. Here's our summary of the other 2. The initial prototypes for both were built with cardboard, straws, and some other materials. The first one was a pedestrian crossing warning light. This one was geared more for the bikers and would illuminate whenever there were pedestrians on the bike path, and that would tell the bikers to yield or stop before they got into an accident. The other prototype was an intersection warning light. This was geared more for the pedestrians and is very useful because they would light up when bikers were on the path. Very often bushes and trees act as obstructions, so sometimes the bikes seem to come out of nowhere. They would be green when the path is empty and red when the path is busy. For both of these prototypes, drawbacks are that it is only a visual warning, and we feel that a better option would have both audio and visual warnings, for example, a speaker.
So in order to test the prototypes, we used a Google Forms that we sent out to people to get their input on it, and we used this for safety and aesthetic, since that's a somewhat opinion-based statistic. And then we used our own judgment and data. We were able to calculate things like how eco-friendly it was by using criteria like percent recyclable, and we could also see how well it withstand the environment or how much it cost just by using some calculations. So that is how we were able to find which prototypes did well in which areas and ultimately decide on a prototype.
I will be talking about our final solution. From our weighted decision matrix, this solution came out as the best mix of safety, efficiency, and practicality. We improved the prototype further by including the suite of TI kit sensors, an ultrasonic motion sensor, an LED, and a speaker system. From our original iteration of this prototype, we made significant changes to optimize the design. This included a more modular design that can attach to both bikes and skateboards, a removable back cover, and a redesigned clamp that is stronger and more versatile. We also plan to distribute these units through the Purdue Police Department for free. Because of the low unit cost of only $15, we expect that Purdue could distribute this design for less than $100,000 to all the bikers and skaters on campus. Although this design was already our top solution, changes improved our design in several key areas. According to survey responses, the design went from an aesthetic rating of 3.5 up to 4.2. The electricity use of the device increased slightly, but this was offset by the use of AA batteries. The cost of maintenance decreased significantly as a result of the new modularity and improved access to key components of the device. Some limitations of our device included the limited battery life of around 2 weeks in normal use and the limited waterproofing as a result of the removable backplate. With further research, we could mitigate both of these issues.
Well, we had a lot of fun with this project. The goal of it was to create an invention or device that would improve pedestrian and bicycle safety on campus and also reduce the number of accidents on campus. Thank you, and we hope you enjoyed our project.